Hello everyone, I'm Steven. In my last video, I did Euclid question 9, and today I'm going to do Euclid question 10. Hope you enjoyed this video, and make sure to subscribe my channel. Let's get into the question now. So question 10 is Carrie has a list of n integers, a1, a2, until an, satisfying that a1 is less than or equal to a2, and a2 is less than or equal to a3, yada yada yada, and that is less than or equal to an. Carrie calculates the pairwise sums of all m equals to a half times n minus 1 possible pairs of integers in her list, and orders these pairwise sums as s1 less than or equal to s2 less than yada 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 less than or equal to sm. For example, if Carrie's list consists of three integers 1, 2, and 4, the three pairwise sums are 3, 5, and 6. And question A is, suppose that n equals to 4 and that 6 pairwise sums are s1 equals to 8, s2 equals to 104, s3 equals to 106, s4 equals to 110, s5 equals to 112, and s6 equals to 208. Determine the two possible lists of a1, a2, a3, and a4 that Carrie could have. Part B is, suppose that n equals to 5 and that the 10 pairwise sums are s1, s2 until s10. Prove that there is only one possibility for Carrie's list, a1, a2, a3, a4, and a5. And part C is, suppose that n equals to 16. Prove that there are two different lists of a1, a2 until a16, and b1, b2 until b16 that will produce the same list of sums, s1, s2 until s120. So let's get into part A now. So we know that a1 plus a2 would be the smallest sum out of these 6 sums. So we will know that a1 plus a2 equals to 8. And we also know that a1 plus a3 is the second smallest sum among these 6 sums. So a1 plus a3 would equals to 104. And a3 plus a4 would be the largest sum in these 6 sums. So a3 plus a4 will equals to 208. And a2 plus a4 would be the second largest sum. So a2 plus a4 equals to 112. Now, a1 plus a4 could be both 106 and 110. So let's consider the first scenario. a1 plus a4 equals to 106. So if we just solve this system of equation, we will have a1 equals to 1, a2 equals to 7, a3 equals to 103, and a4 equals to 105. And now let's consider a second scenario, that is a1 plus a4 equals to 110. And so in this scenario, we will have a1 equals to 3, a2 equals to 5, a3 equals to 101, a4 equals to 107. So there we have our two pair of a1, a2, a3, and a4, which are 1, 7, 103, 105, and the other pair is 3, 5, 101, 107. And now let's get into part B now. Since we know that a1 plus a2 is the smallest sum among these 10 sums, so then we will know the value of a1 plus a2. And we also know that a1 plus a3 is the second smallest sum. So a1 plus a3's value is also fixed. And we know that a4 plus a5 is the largest sum. So a4 plus a5's value is also fixed. And we know that a3 plus a5 is the second largest sum. So A3 plus A5's value is fixed too. So we know the value for these four sums. And then if we add all S1 to S10 together, we will have 4 times A1 plus A2 plus A3 plus A4 plus A5. So then we'll be able to determine what A1 plus A2 plus A3 plus A4 plus A5 is. And since we know the value for A1 plus A2 and A4 plus A5, and so we're able to determine A1 plus A2 plus A4 plus A5. And since we're also able to determine what A1 plus A2 plus A3 plus A4 plus A5 is, and if we just subtract these two values, we'll be able to determine what A3 is. And since we know the value for A1 plus A3 and A3 plus A5, so then we'll be able to determine the value for A1 and A5. And since we know the value for A1 plus A2 and A4 plus A5, then we're also able to determine the value for A2 and A4. So now we are able to determine every value for A1, A2, A3, and A5. Then that means there is only one possible list for Carey's list. Let's get into part C now. Suppose that n equals to 16. Prove that there are two different lists of A1, A2 until A16, and B1, B2 until B16 that produces the same list of sums, S1, S2 until S120. So if we have two lists of integers with length m, and they have the same sum list, then we're able to create two lists of integers with length 2m, and they will have the same sum list in the following way. So if we start with the original two lists, A1, A2 until AM, and B1, B2 until BM, and if we create these two new lists of A1, A2 until AM, and B1 plus 1, B2 plus 1, and until BM plus 1. And the other list is B1, B2 until BM, and A1 plus 1, A2 plus 1, and until AM plus 1. So now I will prove that the new two lists, sum lists, are the same. So there are two types of sums. It will be either the same variables add together, which are a plus a or b plus b, or there are different variables add together, which is a plus b. So in case 2, all of the sum in this form in list 1 would be ai plus bj plus 1. And we could find the counterpart in list 2 as ai plus 1 plus bj. So all of these sums are the same. And in case 1, since we know that the sum list of A1, A2 until AM, and B1, B2 until BM are the same, when we try to find the counterpart for AI plus AJ, there must be BP plus BQ that has the same sum as AI plus AJ. Also, when we are trying to find the counterpart for BI plus BJ plus 2 in list 1, there must be AP plus AQ plus 2 that has the same sum as BI plus BJ plus 2 in list 2. And therefore, we're able to find the counterpart for every pair of sum in list 1. Since we're able to find the counterpart for every pair of sum in list 1, that means both sum lists are the same. So we could start with two lists of 2, then we will have two lists of 4, then we'll have two lists of 8, and finally we'll have two lists of 16. Also, if you already have two lists that their sum lists are the same, and then if we add x or multiply it by y to all terms in both lists, their sum list will still be the same. Now I will provide an example for two lists of 16. So as I said before, let's start with two lists of 2, 1, 4, and 2, 3. So then we could multiply by 2, then minus 1, we'll have 1, 7, and 3, 5. Since we already have two lists of 2, then we're able to get a two list of 4. So then we'll have two lists of 4, which are 1, 7, 4, 6, and 3, 5, 2, 8. Or 1, 4, 6, 7, and 2, 3, 5, 8. So then we could multiply by 2 and then minus 1. We'll have 1, 7, 11, and 13, and 3, 5, 9, and 15. So then we'll have two lists of 8. 1, 7, 11, 13, 4, 6, 10, and 16. And 3, 5, 9, 15, 2, 8, 12, and 14. If we sort these two lists, we'll have 1, 4, 6, 7, 10, 11, 13, and 16. And 2, 3, 5, 8, 9, 12, 14, and 15. And then we could then multiply by 2 and minus 1. We'll have 1, 7, 11, 13, 19, 21, 25, and 31. And 3, 5, 9, 15, 17, 23, 27, and 29. So then we'll have two lists of 6, which is 1, 7, 11, 13, 19, 21, 25, 31, 4, 6, 10, 16, 18, 28, 24, and 30. And 3, 5, 9, 15, 17, 23, 27, 29, 2, 8, 12, 14, 20, 22, 26, and 32. And if we sort these two lists, we'll have 1, 4, 6, 7, 10, 11, 13, 16, 18, 19, 21, 24, 25, 28, 30, 31, and 2, 3, 5, 8, 9, 12, 14, 15, 17, 20, 22, 23, 26, 27, 29, and 32. Okay, so now we have these two lists, and I'll prove to you that these two lists, sum list, are the same by programming. Okay, so now I will prove to you that these two lists, sum lists, are the same. And I already copied these two lists here. So now let's start by two vectors. And let's create these two vectors. Now these two sum lists are created, then sort them. So now these two sum lists are sorted. So let's use a Boolean value. So if one's i's term does not equal to some i's term, then a equals to false. So then after that, if a, then like that. So let's build this. There, we can see that now these two sum lists are the same. And if you want to know these two sum lists, I could do this. Now you can see all the sum here. And every term are the same in these two lists. So there, I proved to you that these two sum lists are the same. Euclid question 10 is quite tough. It requires a lot of advanced thinking to solve it. I hope you enjoyed this video and make sure to subscribe my channel.